Today, I am talking about safety measures against flange climb derailment, considering friction coefficient between wheel and rail. Safety index against flange climb is defined by Nadal's formula for long time ago. This figure shows the mechanism of the derailment coefficient Q by P. Sorry. In my lecture, Q by P is the same as Y by Q or L by V used in European countries. The Q by P is calculated by the value of the flange angle alpha and friction coefficient mu. In the year of 2000, we have serious flange climb accident in Tokyo. After the accident, we are studying the prevention of against flange climb, and the Ministry of Transport decided the safety measure called estimated derailment coefficient ratio. This is the ratio of critical value of Q by P against estimated or actual value of Q by P. The critical value of Q by P is calculated by the modified Nadal formula. By this formula, equivalent friction coefficient mu E is calculated considering the angle of attack. Mu is increasing according to the increasing of the angle of attack, so larger angle of attack reduced critical value of Q by P and safety margin. But it is calculated normally based on mu equal 0.3. The change of mu is not considered. So safety measure consider mu changes is necessary. This figure shows our study after the accident for 20 years. One is PQ monitoring bogies. This bogie can monitor of wheel-rail contact force without strain gauges by using in-service trains every day. We used this Q by P bogie since 2009, about 10 years ago. We collect many huge data of the states, actual states of the wheel-rail contact condition. Another is carving performance tests using the full-scale roller ring in NTSL, our laboratory. This roller ring can simulate the carving condition by using the real bogie. This is a sample of the monitoring Q by P value through the 160-meter radius curve. The Q by P value of each train is increased in the runoff transition curve. This figure shows the Q by P value in four 4 curves of the entire line. According to our measurement by the Q by P monitoring bogie, we grasped the real curving condition. The contact point and the friction is different between the 4 wheels in the same bogie. Leading outside, leading inside, trailing outside, and trailing inside. The contact point and the friction is different between the 4 wheels due to the lubrication from the wayside lubrication. So safety against flange climb should be examined considering the friction condition of each wheel. This figure shows the relationship, the friction coefficient of the flange and the critical value of the Q by P. Q by P is changing according to flange friction. So absolute value of Q by P cannot be decide derailment safety. The margin against critical value is important, which is changed by the friction conditions. To evaluate the flange climb safety, friction coefficient of the flange contact is required, but it cannot be measured by existing measuring method. So we introduced estimation method by using SIMPAC. The detail will be introduced later. So we proposed flange climb index, FCI, as the measure of safety against flange climb derailment. FCI is defined by this formula, the ratio of the real Q by P against critical value of Q by P. In the case where the FCI is larger than 1.0, flange climb is possible. This figure shows high frequency condition and low frequency condition. In the case of the mu is 0.65, the FCI value is excess to 1.0, and in this case, flange climb it actually occurred in this case. But lower friction case, FCI is less than 1, and flange climb not occurred. So we examined different conditions, examine the safety between the different conditions. Condition 1, condition 2, condition 3, condition 4. Yellow is dry and blue is lubricated. This is the value of Q by P. In condition 1, all wheels dry, Q by P 0.5. But condition 2, only reading outside wheel lubricated, Q by P is 0.65, larger than the all dry condition. And in condition 3, the Q by P is smallest, 0.16. But this actual value of Q by P cannot decide the safety. These are the value of FCI. FCI is 0.6 in condition 2, and 0.35 in the condition 2, and 0.22 condition 3, and 0.12 condition 4. This is largest, this is the smallest. So this is most safe. This is not safe. Not according to Q by P absolute value. This table shows the safety ranking of the various lubrication conditions. Condition 4 is best. Condition 1, all dry is not good. Calculation of FCI. For calculation of FCI, mu1 out means leading wheel set and outside wheel friction. mu1 out is necessary to calculation, but mu1 out cannot be measured by existing method. This is difficult to measure, so we propose estimation of mu1 out by using lookup table. This lookup table is calculated by the result of SIMPAC simulation. By using various value, mu or R is radius, various value of output, couple P by P is calculated. This is the friction, this is the longitudinal force. So, and the lookup table is drawn by these variables. So, as inverse problem, in this program, we can get U1 value by using this lookup table. So this is the conclusion. A new measure of safety against flange-climb derailments, FCI, was proposed. To calculate FCI, the actual friction coefficient mu1 can be gotten by the lookup table. Using FCI, the safety margin against flange climb can be estimated quantitatively. Thank you for attention.
Thank you.